Nomenclature: the naming of alkanes, alkenes, and alkynes. All alkanes have a suffix of "ane" as they are saturated hydrocarbons with only single bonds between carbon atoms. Alkenes have a suffix of "ene" as they are hydrocarbons with a double bond between carbon atoms. Alkynes have a suffix of "ine" and they have a triple bond between carbon atoms. Here is a table of all the suffixes and prefixes of alkanes, alkenes, and alkynes. As you can see, the initial prefix of each name, chemical name, has to do with the amount of carbons in each formula. So we have methane for 1, meth for 1, eth for 2, prop for 3, bute for 4, pent for 5, hex for 6, 7 for hept, oct for 8, non for 9, and dec for 10. Then you add the suffixes, as we discussed about a minute ago, onto the end of it, and you get your chemical name. For example, the name of a chemical with 3 carbon atoms with double bonds would be propene. Now you can take a minute to stop and copy this down. There we go. Molecular formula and naming. When deriving the molecular formula from the name of an alkane, you have to remember that there's only single bonds between carbon atoms. So when you draw it, as for example in the left-hand most column, you have your 2 carbons and a single bond in between. The rest are saturated with hydrogens. So you take the number of carbon atoms you have, write it down, and put the 2 with it, then the number of hydrogens you have, and put the 6 with it, and then you have your molecular formula. It's basically the same with alkenes and alkynes, except you have to remember to only put so many as the carbon can handle. So you can only have 8 electrons onto the carbon atoms. Reactions of alkanes, alkenes, and alkynes. All hydrocarbons are capable of combustion-produced CO2 and water. Though single covalent bonds between carbon atoms, or alkanes, may be difficult to break, hydrogen atoms may be substituted by a halogen in a substitution reaction with fluorine, chlorine, or bromine. In all cases above mentioned, the product form is a halogenated alkane, as the halogen atoms acts as a functional group. They are also known as alkyl halides. Alkanes are generally interactive due to the strong covalent bond between the carbon atoms, but it makes a combustion reaction if ignited in air. Alkenes and alkynes, however, are much more reactive than alkanes due to the double and triple bonds, which are weaker. For example, a reaction between ethane and bromine occurs slowly with the addition of heat and ultraviolet light, whereas the reaction of alkenes and alkynes will occur quickly at room temperature. Markovnikov's rule. When a hydrogen halide or water is added to an alkene or alkyne, the hydrogen atom bonds to the carbon atom within the double bonds that already has more hydrogen atoms. This is also known as the rich get richer. Markovnikov's rule also has a really big play in the reactions of alkenes and alkynes. So just keep that in mind